Okay, and I'm going to call this lesson solving for sides, but I'm not going to start with it right away. I will explore a little further. I didn't assign any questions like these, but let's say I'll just call this an example. Okay, let's say you have given that sine of w, let's say, is equal to 2/3, right? Comma, state the ratios of cosine w and tan w. How would you do a question like this? This one goes higher order thinking. Okay? For this one, I'm going to assume that Pythagorean theorem is alive and well in your brains. And some of you might think, oh boy, I haven't done that in a while. And that's true, but I'm hoping that that skill is still very much applicable to what we're doing moving forward. Pythagorean theorem works for right triangles. As long as you know two sides, you can find a third one. Okay, so and I will give you a little shortcut later on how I use it to be a little quicker. Instead of always moving stuff around and manipulating the formula, I have a way to go straight to what I need and then solve right away. Okay. So maybe I will go over that shortcut, right? After this, I will give you a little synthesis. Okay, so sine of w, if you start with that and you know that it's 2/3, okay? If you recall, so, ka, toa, right? This is always true. I could have started with cosine, I could have started with tangent. In this case, they just happened to start with sine. They gave you what sine of w was. And remember, when we do sine, cosine, and tan, it's going to be one of the acute angles of the triangles that we're using here. Okay? And so based on this, because this is sine, I go over here and I remember that sine is the opposite side divided by the hypotenuse of w. So this side here is the opposite to w in particular, and this is the hypotenuse. Okay, I know that. So now you want to, I would strongly suggest you draw a little triangle, right? Doesn't have to be fancy or to scale, nothing like that, right? And position w in as one of the acute angles, right? So we'll position it here just for practical purposes. It's better for it to be there, right? It's easier to work with. Sorry. So if you put w there, then the opposite side to w would be here, and the hypotenuse would be here, and therefore the adjacent would be here. Okay, if you're looking out, if w is your reference angle, then this is true. Okay, so now we know in particular that the opposite side actually has a value attached to it, which is 2, and we know that the hypotenuse has a value attached to it, which is 3. Okay, so we have 2 out of the 3 sides, so I'm going to call this x. Determine x, comma, by using Pythagorean theorem. Okay, we're going to use the Pythagorean theorem, which states that you will probably scratch your head a little bit at my formula because you're so used to ABC, a squared plus b squared is c squared. I don't like that too much, because what if your hypotenuse happens to be labeled A, right? Then it's gonna just completely throw you off. So what I like to do is that I go leg squared plus leg squared is equal to the hypotenuse squared. Okay, so if you remember that, right, take the one leg, square it, take the other leg, square it, add those up, that will be equal to the hypotenuse. It could be labeled X, Y, Z, A, B, C, it doesn't matter. You know the hypotenuse is across the 90. This formula is actually what Pythagoras came up with. This is actually, he did not use A, B, and C, right? He just noticed, hey, if you take the legs, you square them and add, that will always be equal to the hypotenuse squared, okay? This is a leg, right? We know that for sure. So we know that x squared plus the other leg, which is 2 squared, is going to be equal to the hypotenuse, which is 3 squared. Okay. Furthermore, we know that x squared is equal to, oh, I won't move it just yet. X squared is equal to 4, right? Because 2 squared is 4, and 3 squared is 6. You're like, it's not 6. It's 9, right? But this is a common mistake. I still see it. I see it too often. It's worth mentioning it, right? 3 squared is 9. Okay, sorry, I was just throwing you off there. And the 4 comes over, so it's 9 minus 4. X squared is equal to 5. Therefore, x is equal to square root, because we're taking the root of both sides. X is equal to square root of 5. Leave it like that. In this course, you want to leave it as a root. Do not turn it into a decimal. Okay, now we know that this is root of 5. This side here is root of 5. So now you have all three sides in that triangle. And how did it all start? It started by us looking at, sorry, oh, this is sine. Okay, what do I know about sine? Well, that the numbers across will represent the opposite and the hypotenuse. I plugged it in, opposite, hypotenuse. Given that I have two sides, I found the third side by using Pythagorean Theorem. Sorry, guys. I'm gonna have to drink a coffee here or something. There we go. So that's root of 5, right? now we can say, now we can state, right? We can say, hey, so cosine of W, remember, sine, cosine, and tan will always be glued to an angle. If you don't know what the angle is, it's going to be a letter, but never just have it sitting on its own. Don't just say cosine is equal to, it's cosine of something, is equal to, and remember, it's adjacent over hypotenuse. That's what cosine is, because you know that it's this, right? On the side here, we're just going to remind ourselves, right? Adjacent hypotenuse. So you're using your labeled triangle now to figure this out. Tan of W is going to be opposite TOA, right? It's going to be opposite over adjacent. So my opposite is 2, and the adjacent happens to be root 5. Okay, and there you have it, right? So now we were able to answer this. It was a bit of a longer journey, but I need you to still know that that's always very much the case, okay? All right. Before I start, You know what? I'm going to do the Pythagorean theorem shortcut later. I'm going to dive into solving for a side using trigonometry. Okay, so I'm going to cut that off there, kind of like a side. That was almost like an extension. It's not going to be the most common thing you're going to see, but it's definitely going to be asked here and there. Okay, so solving for unknown sides using trig ratios. Okay, and when you see trig ratios, you know we're talking about sine, cosine, and tan. Okay, so solving, this is the title. So we learned how to solve for sides. Yesterday we are now going to learn how to solve for angles yesterday, and today we're going to learn how to solve for unknown sides using trig ratios. The initial setup is exactly the same. It's just solving, it's a little different. Okay, so here we go. I will just give you a little intro here. When you know one acute angle, because the right angle will always be given, the 90 degree. If you know one acute angle and one side, right, comma, we can use trig ratios to solve for another side. Okay, so if you know one angle and you know one side, use trig ratios. You cannot use Pythagorean theorem. You need at least two sides for it, right? So it's going to be very obvious that you have to use one of these trig ratios here. Okay, so example, I'm going to make this triangle like this. And I missed my loose leaf because I need those lines to help me. But it is what it is. Okay, so we have this as being, let's go 60 degrees. This is your unknown side. And let's say that this is 10 inches. So we start with that, and most questions will have capital letters on the corners, right? So we can call this A, B, C. Don't get too fixated with A, B, and C. And also, you may recall that this side length here is technically lowercase a, and that is still correct, but the reason why I put an X in there because it's kind of indicating, hey, solve for this side right here. Can't use Pythagorean theorem, you have to use SOHCAHTOA, right? So what you do is, I'm going to use a different color. If this is your reference angle, right, it's going to be one of the acute angles that we have as our reference. But if this is the reference angle right here, you're almost standing here, then this is your opposite side. This is your hypotenuse, of course, and this is your adjacent. Okay? And remember the don't know, don't care, right? There's one side that we don't know and don't care about. We don't know what the hypotenuse is, and we also don't care in this case. They're not asking for it. So you're left with O and A, right? So if you have to choose, it takes seconds to write it out, right? If you have to choose, you're looking at O and A, the only two sides. O and H doesn't work. A and H doesn't work either. O and A, that's the one that works. Remember, only one of them will work. So we're using this to get us started. Never have this in your formulas or equations, okay? This is just to help us out. SOHCAHTOA, right? So we're gonna go tangent. We have to use tangent, and tangent needs to be glued to an angle, and in this case we know what that angle is. It's 60 degrees. So no letter there, okay? Is equal to opposite, which is x, it's our unknown, right, over 10. You don't need to put the units down because it's going to be in, our answer is going to be in inches. Maybe let's backtrack one more. The equation would actually state tangent of A in this case is going to be opposite over adjacent, right? Taking one step back, this is what we started with. Then we substitute in our values that we know. And here you have to be careful, okay? Here we use cross multiplying and dividing, okay? So what we will do is we'll take this whole side and multiply it by by 10, okay? And then we take this whole side and multiply it by 10 as well. I'm starting to do this because some of you were still not getting that fact when we worked with equations that you had to distribute. In this case, you won't have to distribute, but I think I have to start putting the brackets on what's there and put the number or letter that you're multiplying by itself like that. However, so now we can cancel this out. That's exactly what we want. X is on this side, right? And this other side is going to be 10 times tan of 60. And you can actually calculate that as an exact value. First of all, let's just go find tan of 60. Type in tan, not inverse. We're not using the inverse here. When you're solving for a side, you do not use the inverse. You actually just type it in the way it is. So tan of 60, hit equals. It's actually a value, right? So tan and an angle, don't be scared of it. It's actually just a number. The calculator knows exactly what that value is, okay? So we just have to go like this. 10 times tan of 60. And that is 17.32. And we are in inches. And we're going to round to 2 decimals, right? So now you have solved for that unknown side. That's all that there's to it, okay? What should I say about this to warn you a little bit? It is very important that you put these values in the correct order. If you mix this up, your answer is going to be completely wrong, okay? So putting them in the right order matters. You can't just say 10 up, x down, like because sometimes the variable is going to be up and sometimes the variable, as you will see in a bit, is going to be below as the denominator. Okay, so you're going to have to do some extra work there. So that was one example. Question: could we solve for the hypotenuse now using Pythagorean theorem? And the answer is yes, because now you technically have two sides known to you. We can use Pythagorean theorem to solve that, but I'm not going to do that now because we want to focus on just this skill right here. Okay. All right, so another example. Let me go like this. I want you to be able to be comfortable. The triangle being all flipped upside down in an angle, it doesn't matter. It shouldn't throw you off. So let's say they give you 22 here. And we know that this side here is 4.3 millimeters. Haven't used millimeters in forever, right? In a long, long time. And this is going to be your unknown. So copy that triangle, and then we'll get started. So you see a triangle. Yeah, you try to figure out what is happening here. Okay, I have an angle and a side. Okay, I can use SOHCAHTOA. I can use trig ratios here. This is where you're located. This is your reference angle, right? Let's label the hypotenuse first. That's the most important one. So this is the hypotenuse. Across the angle is the opposite. And this is your adjacent, which is our don't know, don't care side, right? The blank side is the don't know, don't care side. So you may choose to not even label it. And then you always think, right? I'm not expecting you to write this out every time. I do think that it's helpful, right? Having it somewhere on that test or somewhere on that page. So it's O and H, or H and O, it doesn't matter, but they need to be together. So the only one, if you look at the sides, that has it, these two are out, it's sine, right? So we're going to use this as our setup. So here we go. Sine of our angle, which we can use any letter for, we happen to use A lot, is going to be opposite over the hypotenuse. I know that. And I do know that angle, which is 22 degrees. And that angle could be in decimals. It could be 22.5. It could be anything. Is going to be equal to the opposite side, which is 4.3, right? Watch carefully. Opposite, it called for opposite first, which is 4.3, over the hypotenuse, which is x. Okay, so in this case, the variable is in the denominator. Okay, variable in denominator. So watch out for that, right? And so now we're going to do some work with it. So what we do is, whatever's in the denominator, we multiply both sides by it. So we basically say times x times x. Okay, that allows us to cancel out these two because it's x divided by x, which is just 1. It's not 0, it's 1. Okay, then we have x times sine of 22 is equal to 4.3. And then our next step is to remember that this is actually a number, but we leave it like that because we don't want to write down the decimal because it has a lot of decimal places. So we rather just keep it as sine of 22. So now we're going to divide both sides by sine of 22. Which cancels out here. Okay, Lewis. You missed an AC, but it's still good to write down the notes, okay? So basically, you're left with this, okay? Which we can just put the answer right next to it. So I will show you how to do that. And actually, I should have gone back here and just, if you can't type it in the way it is because you have a different calculator, okay, then you need to do as follows, okay? You need to go 60. I can't do it with this calculator. This one is But if you don't have one that shows you what you're typing in, you have to go backwards. You have to go 60, press tan, right? Then you're gonna get a value for, it's basically tan of 60, which is 1.732 and keeps going. Then you take that number and multiply it by 10. Like you're literally going backwards. Okay? That's how you have to do it if you don't have one of these calculators that shows you what you're typing in. In this case, again, I'm going to go 4.3 divided by sine of 22, just like that. 4.3 divided by sine of 22, and that is 11.48. And we are in millimeters. Remember, you're solving for a side length. You're not solving for an angle. How do I know the difference, Mr. Erickson? Well, if you're trying to solve for an angle, you're going to have to use the inverse. That's what we did yesterday, okay? So there is your side length when the variable is in the basement, right? It's in the denominator. It's a little bit more work. So it adds a step, right? So I would say other than this, other than the additional, like setting it up, this is optional, but everything else is must, okay? So I need to see the steps that you're taking. I don't want you to just start with this and then boom, x is equal to that, right? I need to see the whole thing. Okay. Again, we could use the Pythagorean theorem to now solve for that, but we're not going to do that just yet. Okay. Okay. Here you go, another example. And we're gonna go QRS on this one. Let's go QRS. This is sometimes what textbooks do. They just put a question mark. You know, this is 9.6 centimeters. And we know that this is 28 degrees here. I'm going to ask you to try this one on your own, and then we're gonna see how you do. Okay, so opposite I won't care about. Hypotenuse is here. This is my adjacent. A and H, that's right, I'm using this one. So cosine of 28 degrees is adjacent, which is Q over hypotenuse, like that. I multiply both sides by 9.6. Okay, that cancels out, and so I end up with Q on this side, and you may just go and figure out what that is. No problem. That's 8.48 rounded. Okay, 8.48 centimeters, you are correct. All right, next, give this one a try. We'll do one more, and then I will talk about the homework a little bit. You need to practice this. If you ace this, everything else is going to be so much easier. Right? If you know how to solve for an angle, if you didn't do all the homework yesterday for angles, do it today. Okay. So we have this as a reference angle, so that makes this the opposite. That would be the hypotenuse. I don't care about it. This would be the adjacent, right? So O and A, you got to use TOA, right? For sure. So tan of 7.2 degrees. 7.2 degrees, folks, is a very small angle. This is not drawn to scale, but I need you to understand, right? If you look at a straight line which measures 180 degrees, 7.2 would just be a sliver like that. Like it would just be a small angle there. 90 degrees would be up here, right? 45 would be about, right, and right, cutting it in half. 30 is just below it like this, right? 60 is right about there. So you kind of have to have a bit of a reference how to do this and what it would look like in real life. So it's opposite over adjacent. So 4.32 over y. And this is the one where you have the letter in the denominator. No problem, right? Times y times y. Cancel out the y's. You have to write this out one more time. So that makes this a bit more challenging. You divide both sides by tan of 7.2. This cancels out, so y, you can just write down the answer, 4.32 divided by tan of 7.2, and that's 3420. That's correct. Way to go, folks. You either had a really good teacher in grade 9, or you're just very smart and you're picking it up right away. Okay, triangle RST, okay? Just written up instructions, right? There's no diagram provided, so you need to come up with that on your own. And the easiest is to just make it look in such a way that you're used to, right? That's probably the way to go. And then you just go by the information that they're giving you. We know that T is the 90-degree angle, so we need to have T there. We know that S is the 70. I'm going to make it be here. It's just easier. And so it's RST, right? So we're going to put the R there. So in this case, it's RST going counterclockwise. Who cares? It doesn't matter. It'll still work out. Trust me. S is over, where would S be? Side S. Well, it's across capital S. That's where knowing the convention on how to label comes in handy, right? This is S, this is R, and this is T. So this is going to be our grand finale, okay? You got to pay attention to this, okay? So calculate the length of side R and T. So you can't do both. Let's focus on R first. So this is the angle in question. So this would be my opposite side here. Okay. Oh, and which one are you going to solve first? That's the question. So let's label first. Opposite, hypotenuse, adjacent. And you're like, Mr. Dirksen, there is not a, I don't have a don't know, don't care, like which one should I do first? If you're solving for R, you don't care about T, right? If you're solving for R, you don't care about T. If you're solving for T, you don't care about R, okay? That's how you have to approach this. Like it's almost like we're going to do R first, we don't care about T, and then later on we're going to work with T, we don't care about R. Does that make sense? So if we're solving for side R, right, if we're going to do the work here, we're going to say, hey, we don't care about T, so let's cover that up. Let's cover up T. We are left with O and A. Okay, so we're gonna have to use TOA like that. So we're gonna go tan of 70 degrees is equal to opposite over adjacent like that. And we're gonna solve that, and you know already how to solve that. So let's pause for a bit and now go over to side T. If you're solving for side T, right? You care about it, but you don't care about R. So R becomes our don't know, don't care in this situation. You definitely want to keep the 12 that you're given, right? So if you cover up the R, because now you care about T and you know what 12 is, so you kind of ignore the other one. This is our don't know, don't care right now. Opposite and hypotenuse, that's so, right? So basically it's sine of the, oh, yeah, sine of 70 is equal to opposite, which is 12, over hypotenuse, which is T. And now you basically just have two questions merged into one, but it's done the same way. You know how to solve moving forward from there. Notice that I use tan here and then I use sine there. Okay, so let's solve. We would multiply both sides by r. That cancels this out. And so we have r times tan of 70 is equal to 12. Divide both sides by tan of 70. That cancels that. And r is going to be 12 divided by tan of 70, which is 4.37. 4.37 centimeters. Okay. So we know what r is now. And I'm kind of going to just fence this off. Okay. And now I'm going to work with this. I have to do exactly the same thing, except for I'm using different letters, right? T and T, right? Cancel that. Write out one more line. Divide both sides by sine of 70, not tan, right? This cancels out, and then you get 12 divided by sine of 70. That is 12.77. And we are still in centimeters. Let's make something clear. This is the hypotenuse. Therefore, longest side. Always keep that in mind. If you do any of these questions and you're solving for a leg and you do your math and that answer ends up being bigger than the hypotenuse, if it's given, then obviously you did something wrong. You got to go back and check. You probably didn't enter the values right, or you didn't pick the right trig ratio to begin with. And so you need to make sure you keep that in mind. Okay, I will just say this here, homework. I will just go with one page here, even though there are two pages. Oh, there are no page numbers on this one. Oh yeah, there is. I will just say page 3, because page 3, and I will say, how should I say this? Every other one. Do every other one for each question. Example, if it's question 1, just do A. For question 2, do A, C, right? You go A, C, E, G, and so forth. Like, you don't have to do every single one if you feel confident enough. And the answers are at the back, right? So this just keeps going. I'm just asking you to do every other one. Don't do every single question for every question number. Okay, so this is page 3 right here. Question 1, just do the first one here. Question 2, do A, C, or whichever combination you want. Like, you're your own boss, right? You got to figure out, what do I need to succeed, right? Do I need to put in extra time, or do I have enough time as is? Okay. And the key is at the back. Remember that. And maybe I will just introduce I will talk about this one real quick, just so you know what you're doing. It says write the tan, cosine, and sine ratio for each acute angle. So I'm going to use this one because you're going to do this one. So I would label this, I would call this A, and this is B. So then you know these are the two acute angles. So basically what they want is they want sine of A, cosine of A, and tangent of A. And they want you to come up with the two values that should go here. Okay? And they also want sine of B, cosine of B, tangent of B. Okay? They want you to write down based on this triangle. And remember, when you change the reference angle, opposite and adjacent are switched. So use different colors if you're labeling. Okay? Enough talking. That's it.